Function inverses. So here we go. This is our review. What is the domain of the following function? Domain means x values. For what x values is this function valid? For what x values does this function exist? Remember that you cannot divide by 0. Do you guys remember that? So you're going to find all numbers. As long as you don't divide by 0, that's part of your domain. So the x plus 2 is all real numbers. We don't have to worry about that. We just got to focus our time into x squared minus 25. This is the difference of squares. X squared minus 25 is the same thing as x plus 5, x minus 5. So if I expand this, x plus 2 over x plus 5, x minus 5, you see that you have two values that do not exist. X cannot equal 5, and x cannot equal negative 5. If you equal negative 5 or 5, you get a 0 in the denominator, and you can't have that. Does that make sense? By the way, this is just for notes. Vertical asymptotes, you have vertical asymptotes at 5, and you have vertical asymptote at negative 5. And I know some of you are saying, did you have to do the difference of squares? No, you could have just said wherever x squared minus 25 equals 0, x squared equals 25, square root, x equals plus minus 5. And you get the same answer anyways. All right. They wrote it in interval notation. If you, so sometimes kids get confused and they're like, is the answer A? Or because they see the negative 5 and 5. Guys, think of a number line. Here's negative 5, here's 5. You can be all real numbers except for these two. These are the only two that you cannot be. So you can go from negative infinity all the way to negative 5. See? And then you can go from negative 5 all the way to 5. And then you go from 5 all the way to infinity. So there it is. Does that make sense? The only numbers you cannot be is negative 5 and 5. That's, by the way, that's why they don't have a bracket on those, because you can't be that. Yay or nay, guys? Okay, here we go. Let's go to the next one. Find the domain of the following function. Again, so let's see where you cannot be 0 in the denominator. So x cannot equal 6. And what else? We're talking about real numbers, guys. So the square root, the expression x minus 2 must be larger than 0. Or it can actually equal 0 as well. 0 divided by something is 0. So the expression x minus 2 has to be greater than or equal to 0. Does that make sense to you guys? No, tell me, guys, because I can't read mine. Okay. So there it is, guys. So there it is. Just move the 2 to the other side. X is greater than or equal to 2, but it cannot equal 6. So how do you do it in a number line? Like this. Number line, here's 2. And I go forever until you hit the number 6. You can't equal 6. And then after 6, you can go forever to the right. So let's look for that number. From 2 to 6, and then from 6 to infinity. Letter B. Do you see how we did it, guys? Okay. Let's go to question 3. Relax. It's not that bad. It looks bad, but it's not bad. You see how this says f of x? It could have said f of triangle. Do you guys like triangles? If it said f of triangle, you would have just gone triangle squared plus 4 times triangle. I put an x there. Plus 2. So maybe it helps if you put parentheses around wherever you see the x. So whatever expression you have inside the parentheses, that's what you're going to insert for your quote-unquote x. Does that make sense? So here we go. Equals. So all I'm going to do is insert x plus 5. X plus 5, close it, squared, plus 4, parenthesis, x plus 5, close it, plus 2. You're done. All you're doing now is algebra. Let's expand it. X times x, x squared. X times 5, because all I'm doing is folding. X times 5 is 5x. You're going to have 2 of those, so 10x. Do you guys know what I'm doing, guys? Okay. I see some of you guys don't want an answer. It's this. This is what I'm doing. That x plus 5 squared is this. I'm doing this. X squared plus 5x plus 5x plus 25. And there's always someone that tells me that's x squared plus 25. No, that's not. It's x squared plus 10x plus 25. Then distribute the 4. 4x plus 20 plus 2. Are we okay? And there it is, guys. That's it. You're done. X squared, and then combine like terms. Let's see. That's 14x. And then 25, 20, and 2. 25, 35, 45, 46, 47. And there it is. How do we feel, guys? Are we okay so far? Okay. Let's go to the next one. This is probably the hardest one. And relax. It's not as bad as it looks. I think we've done this already before. Difference of quotients. That f of x plus h. So here we go. I need an f of x plus h. So I'm going to write f of x plus h. Close it. Equals parenthesis. Wherever you have an x, you're going to insert x plus h instead. X plus h. Close it squared. Plus 6 parenthesis x plus h. Close it. Plus 3. I'm not doing anything other than finding just this that I circled. F of x plus h. Are we still okay? Let me know, guys. Do we have any issues with that? Okay. Next, I'm folding. Well, I don't like the word fold. I'm distributing. I'm multiplying x plus h times x plus h. What's x times x? X squared. Then I'm going to have x times h. That's xh. But how many of those are you going to have? 2. So 2xh plus what's h times h? H squared. There it is. I got that one out of the way. Then distribute the 6 plus 6x plus 6h and then plus 3. Nothing combines. Leave it alone. I am ready for this in black. So here it is. That in black, f of x plus h is all this. So I'll write x squared plus 2xh plus h squared plus 6x plus 6h plus 3 minus, open parenthesis, f of x. F of x is just this expression again. X squared plus 6x plus 3, close it. All this is over that one single h. Catch up to there. Are we okay so far, guys? Is anyone confused? Okay. Distribute the negative. So here's what you have now. X squared plus 2xh plus h squared plus 6x plus 6h plus 3 minus x squared minus 6x minus 3 all over h. I know I could have just written it in the top line, but sorry, guys. Are we still okay? All right, from there, look at this. I have a positive x squared and a negative x squared. Those zero out. I have a positive 6x and a negative 6x. Those zero out. I have a positive 3 and a negative 3. Those zero out. I want you to observe that every term that you have left has an h on it. Can I factor out an h? So here it is. I'm factoring out an h. Parenthesis. 2x plus, there's still going to be one h left, plus 6. Close it. All over h. What cancels out? The h's. So you're finally just left with 2x plus h plus 6. And we look for that. Good job, guys. You guys did it. This is called the difference of quotients. All right. And then it gets back to easy. It's just you look at a graph and they just tell you which one is true. Roman numeral 1, the domain of g of x, this is called g of x, is negative 3 to 6. Notice negative 3 has a parenthesis. Well, no, it looks like the domain is negative 3 with a bracket. And notice that 6 has a bracket, but notice that this one has an open circle. So this one's false. It should be bracket negative 3 comma to 6 parentheses. It should be like that. Number 2, the range of g of x is negative 2 to 7. I go down to negative 2. That checks out. It's continuous. My biggest value is 7. And that is a solid circle because, it's not an open circle. So that means it is solid up there. So that one is true. Remember, number 2 is true. The y-intercept is 0, 4. Yep, it looks like that 0, 4 is a y-intercept. That's where I cross the y-axis. G of negative 2 is 0. That's a coordinate. That means this, negative 2 comma 0. So I go to negative 2, and sure enough, I do go through negative 2, 0. Does that make sense so far? All right, last one. G of x is increasing on the interval negative 3 to 0, 1 to 3, 5 to 6. Increasing means you're moving up. You read a graph left to right. Between negative 3 and 0, are you moving uphill? Yep, these are x values, guys. That's an interval. Between 1 and 3, so you go to 1 and you go to 3. Am I moving uphill again? Yep, so far so good. And 5 to 6. Here's 5. Here's x value of 6. Between 5 and 6, am I moving up? Yep, it's true. So there it is. So 2, 3, 4, and 5. 2, 3, 4, and 5. Cool or not cool, guys? Is this helping going over these questions? Okay. All right, find the x and y intercepts of the following function. Guys, you don't need a calculator. You can if you want, but you don't need a calculator. I'm just graphing some random graph. The only time, I'm not graphing this one. I don't want you guys to get confused. The only time you cross the y-axis is when the x value is 0. The only time you cross the x-axis is when the y value is 0. Does that make sense? All right, so here we go. To find the y-intercept, plug in x equals 0. So if I plug in a 0, 0 squared minus 4 times 0 minus 21. You just get negative 21. So my y-intercept is 0 comma negative 21. I'm going to look for that first. Out, maybe, out, and none of the above, maybe, I guess. We'll see if it's that one. Now for the x-intercept. The x-intercept. My y value has to equal 0. So remember, this is y. So I'm going to go 0 equals x squared minus 4x minus 21. Here's where it helps to factor. Give me two numbers that when I multiply, give me negative 21, but add up to a negative 4. And you can only do that if the number in front of the x squared is a 1, and it is. Two numbers that when I multiply gives me a negative 21, but adds up to a negative 4. I guess you can also let the answers help you out. Negative 7 and 3. X minus 7, x plus 3. So do that. Does everyone see how we got those factors? Okay, I'm going to repeat it just in case. Two numbers that when you multiply give you negative 21, but add up to a negative 4. Negative 7 and 3. And then all you do, guys, is find what makes this true. Look, that equals 0. What's the only x value that will make that true? If x equals what? 7. 7 minus 7 is 0. And there's another one. What makes that true? If x equals negative 3. So what are my x-intercepts? I'm going to write x-intercepts. I'm going to put colon, parenthesis, 7 comma 0. Open another parenthesis, negative 3 comma 0. And look for that. 7, negative 3. There it is. Letter C. Yay or nay, guys? Okay. Next one. Suppose that f of x is an even function. Is a point. Which of the... Okay. You got to know what the difference is between even and odd. Do you guys remember even function or no? It's okay. You can be honest. An even function. Even is symmetric about the y-axis. And I guess they could also ask odd, so let me write the odd one here. It has this property, f of negative x equals f of x. And then odd, so let me write odd, is symmetric about the origin. And that means f of negative x equals negative f of x. So let me give you an example of what's an even function. Even function. What's an even function? Like this. It doesn't have to go through the origin. It can be... See? It's symmetric on the y-axis. If you were to fold the y-axis, both of them would be overlapped when you fold it. It's like the y-axis is like a mirror type of thing. Cool or not cool? All right. What does it mean to be symmetric about the origin? What does that even mean? It means this. It means that it's like a rotation on the origin 180 degrees. So if you're in quadrant 1, you'll be in quadrant 3. If you're in quadrant 2, the quote-unquote reflection will be in quadrant 4. So this is what it means to be an odd function. Cool or not cool? Okay. All right. So now let's get back to this question. F of x is an even function, -6, -3. So I'm going to go -6, -3, point. And remember, it's symmetric on the y-axis. So if you fold the y-axis, where would that point land? In quadrant 4, what would that value be? 6, -3. Good job, miss. See? That's all it means. Cool, right? Okay. Let's go to the next one. Determine whether the following function is even, odd, both, or neither. Okay. It doesn't go through the origin, so it's neither. But let me tell you why, though, because I don't want you guys to just be a robot. Remember that an odd function has to have this property right here. So I'm going to insert -x and see if I get negative f of x. So here we go. F of -x equals -x to the 5th power plus -x to the 3rd power minus 2. Negative times the negative times the negative times the negative times the negative is a negative. So -x to the 5th minus x to the 3rd. Okay, go ahead. It's like nothing happened. All right, here we go. I want you to observe something, guys. If I were to factor out a negative, x to the 5th plus x cubed plus 2, this is not f of x. See? If this would have been a minus, I guess it would have been f of x, and it would have been negative f of x, which then would have had this like this. But because this is not f of x, not f of x, and it's not even, we didn't get this, f of -x equals f of x. So it's neither odd or even. Does that make sense? Yeah, if we would have had this situation, if we would have had negative parentheses x to the 5th plus x squared minus 2, this is f of x. So if we would have had this, then it would have been odd. But we don't have that. Cool? Okay. All right, let's go to the next one, guys. All right, describe how the graph of G is obtained from the graph of F. Hopefully, all right, guys, focus. Oh, wait. Okay. All right, this one here, guys, should be pretty straightforward. What does this x minus 4 do to this function? Moves what? Yeah, how many times? Moves 4 right. That 3 is a vertical stretch by a factor of 3. Vertical stretch by a factor of 3. And what does this minus 5 do? Vertical shift down 5. And we look for that. Letter D, stretch vertically by a factor of 3, vertical shift 5 units down, horizontal shift 4 units to the right. There it is. All right. State the translation of the key point 0, 0. Guys, here's what they want to know. They want to know where the endpoint moves. They're talking about the parent function, y equals square root of x. Y equals square root of x looks like this. So they're talking about where does that point move? Without a calculator, I mean, I guess if you use a calculator, that's fine. But without a calculator, this moves like this. How do you tell? Factor out a negative, so that x can be turned into a positive. X minus 2, close it, plus 4. So here's how it moves. It moves 2 to the right and 4 up. 2 to the right, 4 up, and then that negative makes it go like this. This negative makes it move left instead of right. And there it is. C. Cool or not cool? All right, let's see. Okay, let's go to the next one. All right, you're suppose that the point 2, 3 lies in the graph of the function f of x. If the function is transformed, so they're telling us how they're transforming it, guys. Which of these would be the coordinate of 2, 3 under the transformation? All right, here we go. What does that 4 do? All right, guys, focus. Vertical stretch. What did that x minus 3 do? What did it do?
To the right.
Horizontal shift. Right 3. No, she was right. What did that plus 6 do? Vertical shift. Up 6. No, it's all good. It's a safe space. All right. This is why I'm emphasizing what to write, horizontal and vertical. All right, guys, focus. Do the horizontal shift first. So that 2 is now going to be, you're going to move how many times to the right? 3. So that 2 is now going to be 5. Does everyone know how we got the 5? Yeah, perfect. Just add it to the 2. All right, now you see how this says vertical stretch and this says vertical shift? That affects the y value because it says vertical. So you're going to do this one first, the vertical stretch. And then once you do the vertical stretch, then you do the vertical shift. So here's what you do. You take the 3 and do the vertical stretch by a factor of 4. So that means multiply the 3 by the 4. So what's 4 times 3? 12. So I'll write it here. 3 times 4. Here's your vertical shift, your vertical stretch. And now once you do that, now you do the vertical shift. So vertical shift, so that means plus 6. And what is that? 18. So there it is. That's my new point, 5, 18. Does that make sense, guys? Okay. Let's go to the next one. This one's pretty straightforward. F of negative 2. You look at the F line, the F graph, go to negative 2. F of negative 2 seems to be 4. So 4, the y value. And now I'm going to go to G of 2. So go to the blue line. I know yours is not color-coded. That's okay. Go to the blue line. G of 2 seems to be 5. So there it is. 5 plus 4 is 9. And then we just go to 9. Cool or not cool? Okay, let's go to the next one. This is just a simple domain question, guys. So find the domain. This is the numerator, this is the denominator, so let's write it out. 6x squared minus 4x over x squared plus x minus 20. We don't care about the numerator because the numerator is all real numbers. We just know we can't divide by 0. So I look at the denominator, 2 numbers, and multiply give me negative 20, but add up to a positive 1. What is that? 5 and 4. And the 5 has to be bigger because I have to add up to a positive 1. So x plus 5, x minus 4. So what numbers can you not be? X cannot equal 4, and x cannot equal negative 5. Because those are values that will give me a 0 in the denominator. You read a graph left to right. So from negative infinity all the way until you hit negative 5, but do not touch negative 5. I guess I'll do a number line. Negative 5 and 4. So this helps. Negative infinity all the way until negative 5. Then from negative 5 all the way to 4. And then don't touch 4. And then from 4 all the way to infinity. So we look for that. Negative infinity all the way to negative 5. Negative 5 all the way to 4. And then 4 all the way to infinity. Yeah, see, you got to be careful. It's not A. And you remember, no brackets. You can't touch those values there. Cool or not cool? Yeah, we're going to talk about rational functions coming up pretty soon, guys, because we need to know about them. All right. This right here, don't get confused. That's just a composite function. All that means is this. G composite of f evaluated at 0. That's all it means. F of 0. When x is 0, so we're going to look at the f graph. When x is 0, the output is 2. So this is G of 2. So I go to the blue line now. When x is 2, the y value is 5. So there it is, 5. Cool or not cool, guys? Okay, let's go to the next one. Give the following functions, find f composite of g. So this one means f composite of g like this. So that means put the g inside of f. So you're going to write f parenthesis 5x minus 2 close it equals, and now it says x squared for f, so you're going to open parenthesis, write 5x minus 2 close it squared plus 2 parenthesis 5x minus 2 close it. We're going to go slow, so don't worry. You guys ready? Tell me when you guys are ready. Are we ready? What is 5x times 5x? What is it? 25x squared. Good. Then you go 5x times negative 2. What's that? Negative 10x. But how many of those are you going to have? 2 of those. So it's going to be a negative 20x. Good job. Negative 2 times a negative 2. Positive 4. And now we're going to distribute this one. 2 times 5x, 10x. 2 times negative 2, negative 4. All right, we're done. We're just going to combine like terms now. Positive 4, negative 4, 0 out. Negative 20 plus 10, that's a negative 10. So you have 25x squared minus 10x. Cool or not cool? All right, we're almost done, guys. All right, this one might actually be easier than the 15. It says G composite of f at 5. So evaluate f of 5 first. F of 5 equals 5 minus 4, which is just 1. Whatever that output is, that's going to be the input for G. G of 1 equals 4 times 1 minus 2 times 1 squared. 4 minus 2. So 2. Ask. Next one. Okay, what's a one-to-one function? Passes vertical line test and horizontal line test. Every x has a unique y, every y has a unique x. Three x squared plus 4. It's a parabola. Does the parabola pass vertical and horizontal line tests? Trav, I don't know what you mean by horizontal vertical line test. If you draw a vertical line, it only crosses it once. That one it does, but if I draw a horizontal line, it crosses it more than once. So is a parabola 101? No. Roman numeral 2 is another parabola, just shifted to the left 5, and a vertical stretch of 2. Does a parabola 101? No. Roman numeral 3 has an absolute value. All absolute values, all of them look like these. Well, all of these absolute values, unless it's like an x squared, then it'll look like a bird. So our absolute value is 1 to 1. No. And then finally, 3 squared of x minus 5. That, all square root functions look like this. Well, if it looks like this simple, looks like that. Is that 1 to 1? No, that one is. It passes a vertical line test and it passes a horizontal line test. It only crosses it once on each. So just Roman numeral number 4. Cool? All right. This means inverse. So that means that negative 4 was a y value on f of x on your original. That's what it means. Excuse me. On original. So I look for negative 4 as a y value on original. Here it is. So the x value is negative 2. So that's what this is going to spit out. Negative 2. Why? Because it reflects across the line y equals x. So the x's become your y's become your x. So negative 2. Does that make sense, guys? Okay. Go to the next one. F and G are inverses. F of 5 equals 2 and f of 2 equals 3. What is G of 2? Okay, that 2 is a y value on f. So I go to f and I look for the y value. There it is. So if the y value is 2, that means this is going to output. What is this going to output? 5. Yeah, your x turns to your y turns to your x. That's the definition of an inverse. It reflects across the line y equals x. Yeah, we'll go over it again. Find the inverse function of the given function if possible. It is switch your x and your y. So go x equals, this is like a y. This is like saying y equals. X equals square root of 2 minus 4y. Your job now is to solve for y. So I'm going to get rid of the square root by doing what? Square, yeah. You can say it loud and proud. It is a safe space, guys. Square both sides. So now I have x squared equals 2 minus 4y. Now I'm going to move the 2 to the other side. So now I'm going to have x squared minus 2 equals negative 4y. And now I'm going to divide everything by negative 4. So how did they write it? They wrote it, okay, I see it. So they did this. So they did negative 2 divided by negative 4. That's a positive 1/2. And then x squared divided by negative 4. That's going to be a negative 1/4 x squared. And then that equals your inverse. So f negative 1. But before, obviously the answer is letter C. But I want you to notice, oh, none of them are the same. What if there would have been another one that had the same answer, but it has a different domain? Okay, real quick, write this down somewhere. The range of the original, write this down. The range of the original is the domain of the inverse. The range of the original is the domain of the inverse. What's the range of this function? Well, the smallest it can go, the output is 0. So that means my domain has to be x greater than or equal to 0. The range of the original is the domain of the inverse. Cool or not cool? Cool. All right, let's go. Keep going. Use the properties of inverse functions to determine which of the given functions are inverses of each other. Okay, do you guys want to see the hack? All right. You know that the original slope is always change in y over change in x. But when I take the inverse, remember that it reflects across the line y equals x. So that means your x's turn to your y's turn to the x. So when you take the inverse, your slope just turns into the reciprocal. Change in x over change in y from the original. So what's this slope originally? 4. So what's the reciprocal slope of 4? Just flip it. That's like 4 over 1. What's the reciprocal of 4? 1 over 4. So look for 1 over 4. There it is. It's f and g. See, this one has a negative, so it can't be that one. That's opposite reciprocal, so that one's perpendicular. Okay, I know. Some of you want to see it the right way. Chav, I don't want the hats. Show me the right way. Okay, here's the right way. X equals 4y plus 2. Remember, we're solving for y. Move the 2. X minus 2 equals 4y. Divide by 4. So y equals, let's see, how am I going to write it? I'm going to write it the way they have it. Negative 2 over 4, that's a negative half, plus 1/4 x. OMG, look, there it is, f and g. You see how we did it, guys? So f and g. All right, question 22. Find the following functions. Find f of 2p. Just plug in 2p, guys. F of 2p equals, parentheses, 2p close it squared over 2p plus 2 minus 2p. 2p, when I square it, that turns to 4p squared over 2p plus 2 minus 2p. Okay, let's look for that. There it is. That's how you're doing. Oh, because it's 2p quantity squared. So the law of exponents. Whatever you have there, this 2, I'll write it here on the side. That 2p squared means 2 squared p squared. And then 2 squared is 4. See? Does that make sense? Okay. Yeah, keep asking, guys. Those are good questions. Those are good questions. Hit me. Okay. Drop it low. Okay, I'll stop. I don't know how drop it low has anything to do with this. All right. Given this function, find the difference quotient. Okay, here we go, guys. So here's the hard part. I just need f of x plus h. Ooh, so we might have issues with common denominator here. F of x plus h equals 2 over x plus h. You can put it in parentheses, but then we would just drop it plus 4. So now I'm going to write this sign right here. So I'm going to change it to black here. I'm going to write 2 over x plus h plus 4 minus f of x, which is 2 over x plus 4 all over h. Is everyone okay so far? Okay. I need a common denominator. So that means I'm going to multiply this left one here by x plus h plus 4 over x plus h plus 4. And I'll multiply this right one here by x plus 4 over x plus 4. When I do that, here's what I'm going to get. 2 times x is 2x. 2 times 4 is 8. And then I'm going to minus, and then let's see, all this is over x plus 4, x plus h plus 4, close it, minus, so let's see, 2x plus 2h plus 8 over x plus 4, x plus h plus 4, all this is over h. I'm about to combine them. So here we go. 2x plus 8 minus, so this is like a parenthesis, distribute the negative like that, see? Minus 2x minus 2h minus 8 all over x plus 4, x plus h plus 4, and all this is still over h. Don't worry, we'll finish right now, guys. Side note, a over b divided by c is a over bc, because that's like saying c over 1. Keep, change, flip, a over b times 1 over c. Notice a over bc. So I can just move, notice the c just goes right next to that b. So I'm just going to move that h right there. So here's what I have now. The 2x 0 out, the 8 0 out, and I have, this is what I have, negative 2h over x plus 4, x plus h plus 4, h. Because I have inverse operation, and I'll slow down so you guys can catch up. What cancels out? Yeah, the h's. I have inverse operations. I have a product on the top, a product on the bottom. This h with this h. And there it is. I just have negative 2 over x plus 4, x plus h plus 4. Cool or not cool? All right. Last two, and then we're done. I always think it's easier to just plug in a 2, but my kids always seem to disagree, so I'm just going to tell you what my kids think is easier. It says find the y-intercept of this. So they plug in an x minus 2 wherever they have an x's, which I think is harder, but that's fine. 4 parenthesis x minus 2, close it, squared, plus 6 parenthesis x minus 2, close it, plus 2. And then they they FOIL this out, or they distribute this out. 4 parenthesis x times x is x squared, x times negative 2 is negative 2x, but you have 2 of them, so minus 4x. Negative 2 times negative 2 is a positive 4. Parenthesis, and then plus 6x minus 12 plus 2. All I did was distribute. I'm about to distribute this 4. So let's see. 4x squared minus 16x plus 16 plus 6x minus 10. From combining these two. All right, finally. 4x squared, and then I have a negative 16x plus 6x, so that's going to be a minus 10x, and then 16 minus 10, that's going to be a plus 6. And then they get to here, and now they're like, whoa, okay, the y-intercept happens whenever the x value is 0. If I plug in a 0, the only thing you have is what? And then they answer that. I think that's hard. Look at all the work you have to do. I think that's hard. This is a horizontal shift to right, correct, of this function. So if it's a horizontal shift 2 to the right, that means all I got to do is look at my point at negative 2. If I look at my point at negative 2 and I move 2 to the right, that's going to be right on the y-axis, right? So I plug in a -2 into this. So look, 4, -2 squared, plus 6, -2, plus 2. -2 squared is 4. 4 times 4 is 16. 6 times -2 is 12, plus 2. 16 minus 12 is 4. 4 plus 2 is 6. I think that's way easier. But my kids in the past have said, no, you lost me. Why you use -2? Like, guys, well, this is a horizontal shift 2 to the right. So if you pick a point 2 of the original 2 times to the left at -2, and you move 2 to the right, you'll be on the y-axis because the x value is 0 there. So I think this is easier, but my kids are like, no. So they do that. I'll leave it up to you what you think is easier. All right. Last one, and then we're done, and then you should have enough time for just to make an attempt here. Final linear function of f with y-intercept of 3, and this is the inverse. So they don't want they want f. So that means on original, my point is -1, 0. So for you visual learners, -1, 0, and then I have a y-intercept of 3. So there it is. I want this line. So my slope, let's see, I go up 3, right 1, so my slope is 3, and the y-intercept is 3. So y equals 3x plus 3. There it is. Do you see how we did it, guys? I'll give more details. Y equals mx plus b. The b is a y-intercept. They already tell me what it is. And then I just found the slope. I went up 3 times, right 1 time. So my slope was 3, so m was 3. Cool. All right, we're done, guys. Log into UH, at least make an attempt, please.